In this example, we are asked what is the domain and range of the function y equals x squared minus 3. We're supposed to represent both as an inequality and using words. So just to start off with, I'm going to use inequalities, and I'm going to use a little trick to kind of help me out with it. So starting with domain. Domain is x values. So what I'm going to do to help me figure out the domain is I'm just going to start shading or covering up the graph from the outside and work my way in until I reach the graph. I'm going to start with the lower side, the negative side. I'm going to go until I touch the graph. So I hit the graph right there. And as you can see, where I hit the graph, it runs off. So it's going to keep going and going and going and going in the outwards direction, which is going to put us eventually reaching negative infinity. And I'm going to use a stencil with kind of less than x less than. And then on the other side, I'll do the same thing. We go until I touch the graph. Get to the graph there, and again, you can see it's running off and outwards. So now it's going to keep going, and this time it's going to go to positive infinity because we're on the positive x-axis side. You should also stop and ask yourself about the inequalities. Should they be equal to? Well, you can never actually reach infinity, so the infinities will never actually be included. As far as turning this into words, we can just say all real numbers. Now for the range. Range is the y value, so I'm going to use the same kind of strategy. Switch my highlighter real quick. So for the range, I'm going to start at the bottom. Again, I'm starting at the negative side. I'm going to use the same kind of stencil. We'll have a number less than y, less than a number. So we're going to have that same kind of stencil and just kind of fill in the blanks. If I start from the bottom, and we'll go upwards, get to the graph right there. This time you can see it's not running off. It actually stops at negative 3. And because I actually touched the solid line there, we are going to include the negative 3. Then I'm going to do the same thing from the top. From the top, I hit the graph right away, and you can see it's running off once again. So we're going to assume it keeps going and going and going, this time to positive infinity because we're on the positive axis. You can also write this inequality without the infinities as y greater than or equal to negative 3. You usually, on multiple choice answers, would not see the infinities wherever possible. And as far as words go, y values is greater than or equal to negative 3. And that's it. In this example, I'm supposed to state the domain and range of the function graph below. We're asked specifically to state it in set notation, set builder notation, and interval notation. To start off with, though, I'm going to use the same format as I did before. I'm going to give myself a little bit of extra room, though, so I can change it into the set builder notation. So starting with domain, give myself about yay much room. Then I'm going to have the same sort of stencil. We'll have a number less than x less than a number. I'm going to use that to kind of get started here. For domain, I'm going to do the same thing as I did before. I start from the left side and go until I touch the graph. And we get to the graph right here this time. It's not running off, so we actually place the number. The number is -2. And you can see it's a solid dot there. If it is an open dot, we wouldn't include it, but solid dots and solid lines are included. Now going from the other side, we touch the graph pretty much right away, and we can see it's running off. So infinity. And remember, we're talking x values, and this is the positive side for the x-axis. So it's positive infinity and not negative infinity, even though it's going in the downwards direction. As far as turning this into set builder notation, this is the inequality notation. To turn it into set builder notation, we simply add a little bit of extra stuff. We'll just add x such that vertical line is read as such that x is between negative infinity and, or -2 and infinity. And that's set builder notation. Just like the other one, you can also get rid of the infinity, writing it as x greater than or equal to -2. As far as the interval notation goes, that's with the parentheses and square brackets. So our two key points or numbers are -2 and positive infinity. Since the -2 is included, we use a square bracket on that side. And since the infinity is not included, we use a parentheses on that side. And this is interval notation versus set builder. Now we're going to take a look at range, doing the same thing. I'm going to leave myself a little bit of space and give myself that same sort of setup. Oops, might not be equal to. So we have our room for all of our numbers. Now let's start shading. I said this in one of the other examples, but you don't actually have to shade. You can easily just cover it up with like a sticky note or something. But if you start from the bottom, we can see we hit the graph again right away. It's running off. So negative infinity. My recommendation is always start with a negative axis. Makes it a little bit easier to do this. And then from the top, working my way down until I get to the graph. I get right to the graph right there. This is again a solid line where I touch my graph. So it is going to be included. So we're going to have equal to, and the y value there is 1. Now to change it into the correct format, so we have our y such that y is between negative infinity and 1. Again, you can change this into, or get rid of the infinity and write the inequality as y less than or equal to 1. And as far as interval notation goes, our two key numbers or bounds are negative infinity and 1. Negative infinity can never be included. And since we have the less than or equal to sign with the 1, we're going to have a square bracket. Now, just some caution when using this strategy. One key thing is, depending on the type of function, it might have asymptotes. So as we move throughout the course, it will become more apparent when those are. So you do have to have a little bit of an idea about the function in order to completely get the domain and range correct. On top of that, the strategy is good, but there are some times when the picture of the graph might be deceiving and throw off what you expect it to be. So please just be careful as you use this strategy. Okay, in this example, Willis is taking a trip to his grandparents' house, who lives 300 miles away. They can travel 60 miles per hour the whole trip. What is the domain and range of the situation? In order to do domain and range, we first have to know what the independent and dependent variables are. Independent variable, which is usually represented by x, and the dependent variable, which is usually represented by y. Now, as far as the independent goes, typically when you have a situation, it's typically time. And in this case, it is as well because time determines how far you've gone. If only a minute has passed, you haven't gone very far from your own house. But if 3 hours has passed, you've gone quite a distance away. So time is our independent variable. The dependent variable is basically what we're trying to look for and is determined by the independent one. So since we're traveling total of 300 miles, that distance is going to be our dependent variable because it depends on how long we have been traveling to determine how far we have gone. So that's distance traveled. Now, as far as domain and range goes, I'm going to start with the range because that's a little bit easier to pick up on. So for the range, since that's the distance traveled, we initially start with 0 distance traveled and we end with 300 miles traveled. The reason why we're starting at 0 is because we're assuming we're starting wherever we are. Starting is our starting point, which means we haven't traveled anywhere from the starting point. Less than or equal to, because we are starting at that 0. Y. Less than or equal to, because we're going to get to our destination after we travel 300 miles. That 300 will be at the destination, which is where we're going to, so it will be included. As far as the domain or the time goes, the possible times, it wouldn't make sense to have any negative times, but when do we know we're done with the trip? Well, that can be easily calculated. If we're going 300 miles away and we're driving at 60 miles per hour, we just need to figure out how many hours that is. We can do a little bit of math. Taking the 300, dividing it by 60, giving us 5 hours. So we know that the time we've been traveling ranges or spans from 0 to 5 hours. And of course, we're starting at 0 and ending at 5 hours. And there we have it. That's the first time I've ever actually